Chalo, laminar flow, let's get started. So basically, it's basically formula driven chapter. Second thing that I need to clear you, there is a two type of flow. There is a normal flow, there is a Corti flow. Corti flow is the relative velocity between two plate moving in a direction. It can be moving in the same direction or it can move in the opposite direction also, but we need to see what is Corti flow. Okay, let's take it easy, go by small things. So here number can take flow, no intermixing of fluid that is happening, no random fluctuation of velocity that is also happening, there is no shear stress. Newton law of viscosity is sufficient to calculate the shear force. Unlike the force, there was a tau rule and that was there for the turbulent flow. But in this case, there is nothing like that. It is so simple. Now, flow part is a dust particle, then a settling of impurities. These are the example. Now, our general value for this that Reynolds number less than 2000, that is called as laminar flow. Okay. And then the parallel plates, like that for a parallel place, it should be ideally Reynolds number less than 1000. And open channel flow, that can be a Reynolds number less than 500, and flow part for a sphere, that is ideally less than 8, which is not very important, but I am just giving an idea. Syllabus: laminar flow through pipe, laminar flow through fixed parallel plates, and then Corti flow. Okay, these are the three things. Flow through pipe, flow through to fixed parallel plate, and then so there is a plate, there is a distance r, that is the r, there is a small r, that is small distance we are taking, just nothing. There is a y, the remaining part we are just marking it as y. Okay, now dy equal to, changing dy equal to 0 minus dr. So why it is happening? Dy equal to r minus r, you can see very simple. Dy equal to 0 to, that is dr, dy minus dr. Now tau equal to dp by dx into r by 2, that is the simple formula that we have derived previously. Back any chapter, you remind what chapter. Mu into du by dy, mu into minus dy by dr equal to this thing, minus dy by dx into r by 2. Then everything, differentiating, integrating everything, the main formula, just keep this in mind. Mu equal to 1 by 4 mu dv by dx cross r square plus c, that is constant. Now for r equal to r, that is the total thickness, mu equal to 0. So in that case, the c equal to 1 by 4 mu dv by dx cross r square. So what will happen for the local velocity for the laminar flow, that would be 1 by 4 mu 1 by 4 mu minus dp by dx r square minus r square. Okay, local velocity decrease it with probability with respect to r. Maximum velocity attained at the central line, where at the central line maximum velocity. Okay, so u max equal to 1 by 4 mu, because r will be 0, so the small r will be 0, it is the whole r. 1 by dx, 1 by 4 mu minus dp by dx, so it's r equal to 0 now because it's r, so r square. And u equal to this thing, u max equal to this thing. So if we just derived u by u max, that is 1 minus r square by r square. Then the discharge, there is many more formulas, so just keep in mind. Discharge value, that is u equal to dq equal to u into dA, dq equal to u dot dA. Okay, a dot v, so u dot v, a dot v, you can see dA dot v, everything d dot a. So right now just writing. So u equal to u max into 1 minus 1 by r square, everything just put, and q equal to pi by 8 mu minus dv by dx r to the power 4. Average velocity, that is u average equal to u max by 2, and v equal to 1 by 8 mu dp by dx r square. So it is v, velocity. This is q, discharge, that is q equal to pi by 8 mu minus dp by dx r to the power 4. It is r to the power square. U max v equal to, so this thing. Now the ratio of r by bigger r, it is 1 by root 2. So smaller is the r by 1 by root 2, so 0.70 are bigger r. Generally alpha value 2, beta value 1.33. Now the pressure drop variation, how much it is happening, that is minus dp by dx into delta p by delta l. How is happening, you can see. So delta p, that is the pressure drop, is just 8 mu l by r square, 8 mu l divided by r square. Delta p is equal to r square equal to d to the power 4, we can see. So 832 mu v l by d to the power 4. Formula for discharge, so delta v, we can also write delta p equal to 128 mu ql by pi d to the power 4. Head loss, so now the next formula is head loss, so d square to d4. So how is happening? So there is a change. H equal to 32 mu v l by pi d square, and that is 128 mu q l by pi lambda into d to the power 4. There is a q that is happening. Power loss is rho q gh. PL equal to 128 mu q L by pi d to the power 4. Mu q square L. So pi mu q square L. So h value is there, no? So lambda is getting distracted. Lambda is getting distracted. Q is getting square. 128 mu q square L by pi d to the power 4. Just imprint in the brain. Friction coefficient, you know that tau 0 by half rho v square. Tau 0 by half rho v square. From there we can get everything. Friction coefficient, fanning friction. So that is f dash equal to 64 by Re. And 4f dash equal to 64 by Re. So local velocity, average velocity, discharge, dp by dx, p by lambda, and rho ql. Fanning friction is 64 by Re, 4f dash by 64. So only horizontal pipe. Equivalent horizontal pressure, that minus tau equal to dp by dx r by 2 we can say. Okay, so 50% done, 50% rest will do. So laminar flow in fixed parallel plate. So fixed parallel plate. So two plates are there. There is a laminar flow that is happening. That is the dy, that is the length, that is the dx, that is also the length. So fx equal to m dot vx. So vx is the momentum change. So momentum change is v2 minus v1. So as v2 equal to v1, there is the both parallel pipes equations. Fixed parallel plate, na? So equation and the length is same. So everything tinkering. So we are getting the main equation that we use very much. So velocity for a laminar flow is that mu equal to 1 by 2 mu dp by dx by minus y square. So 1 by 2 mu minus dp by dx by minus y square. Okay. So parabolic velocity profile, how is happening? That is the b is the length. B is the length, total length, width. Also we can say maximum velocity where it is happening for a parallel pipe. Remember something different, that is b by 2, and u max equal to 1 by 8 mu d by dx b square. It is u equal to 1 by 2 mu minus dp by dx by minus u square. Okay, then there is a discharge. So the discharge value is that q equal to 1 by 12 mu dp by dx b cube into w. W is perpendicular width. Now average velocity, v average, you can see everything. So v by u max, that is 2 by 3. This is the, so pressure drop is there. So delta p, there is a pressure for a parallel plate flow is the 12 mu v l by b square. Okay, then delta p also you can, in terms of discharge, we can write this as 12 mu q l by b q into w. 12 mu q l by b q into w. So h equal to 12 mu q l by lambda into b square. H, it is 12 mu q l by lambda into b square. Got it? The next thing is the power loss. Power loss equal to 12 mu q l by b cube into w. Then the shear stress for parallel plate, that is, it is important for the questions. So minus dp by dx b minus 2y by 2. So how is happening? So mu into du by dy. So that is the value we are just putting, we are just eliminating things up, and then this thing is coming. Now wall shear stress tau 0 equal to minus dv by dx into b by 2. So this is the wall shear stress. Summary, so basically the summary, so mu equal to 1 by 2 mu minus dp by dx by minus y square. So y equal to y by 2, u max equal to 1 by 8 mu dp by dx into b square. Discharge equal to q into a into area into velocity. So velocity, area equal to b cube. There is a b cube is coming and w is width is coming, so nothing extra. So width is into b into, sorry, not w, is a, is multiplying 1 by 12 mu into minus dp by dx b cube into w. So velocity is minus dp by dx delta p by l. So delta p is 12 mu q l 2 mu v l by b square, or 12 mu q l by b cube. 12 mu q l by b cube, where q is the a into height. Q equal to area into velocity. So velocity equal to क्या होगा, q by a. So a means w, so q by b into l, also you can say q by b cube we are coming. So head loss delta p by lambda. So 12 mu v l by lambda into b square, or 12 mu q l by lambda into b cube. Power loss is for the parallel pipe lambda q l by things, and pl equal to 12 mu q l by b cube. So tau for shear stress, the value is tau equal to minus dp by dx b minus 2y by 2. Wall stress is tau equal to minus dp by dx into b by 2. When not horizontal pipe, it is replaced by p square, p by p square. Now for a Cauchy flow, the relative flow. So Cauchy flow is that parallel plates such as the moving relative to each other. So we know that is the y. So let us, that is the y, and also we are getting a u. There is a bigger u, there is bigger b. So y u by y u by, so u by y is equal to বড় হাতের u by b. Got it? So mu equal to u y by b, mu equal to u y by b. Just visualizing that u by y, how is happening. So we just separated the flow in a pressure plus in a normal flow. So these two, we are just mixing this. There is a laminar flow, there is a Corti flow. Just we are evolving curve. So forward Corti flow, for where laminar flow takes place same direction which is moving the plate, in which it is parallel plate moving করার জন্য this is the profile and this is the laminar flow. So this, it is a backward flow. So one is moving down is and one is moving there. So dp by dx is less than 0, and dp by dx is pressure variation greater than 0. So backward body flow dp by dx is positive. So formula is, there is a mu, that is mu equal to, so velocity of simple coating flow and velocity of laminar flow. So mu into y by b, u to y by b, that is a normal between the parallel plate, plus 1 by 2u minus dp by dx into by minus y square. And rearranging those equations, that we are getting u into y by b, 2 by 2 mu minus dp by dx b square, then y by b, and then y by b then whole square. Most important term, that is dp by dx, that is the pressure gradient. So discharge is simple, q equal to q simple Corti flow and q laminar flow fixed parallel plates. It is 1 by mu bw, half mu bw, plus 1 by 12 mu minus dp by dx b cube into w. That is a simple Corti flow between two fixed parallel plates. That the equation we are putting, and we are getting the main simple answer. So rearranging those terms, that we are getting that qy bw average velocity, that is 1 by 2 mu, 1 by mu minus dp by dx into b square. So a whole lot of equation, but this is last, I promise. So tau for shear stress for the Corti flow is this mu into mu by b minus dv by dx b minus 2y by y 2. Okay, got this? I think it's a wrap for laminar flow. So then next flow under pipe, that will come.